Hey, we're starting a new unit today. It is acids and bases. I really like this one because it has to do a lot with what we're doing in real life. Acids and bases we're working with all throughout life. So the first thing you picked up as you came in was a pH activity. It looked like this, and it had a pH colored thing attached to it, plus a piece of paper. What you're going to do is you're going to take this home, and that piece of paper you're going to cut into 20 pieces. Then you're going to test 20 things around your house. No urine, no feces, no blood. I don't care if it's from human or pets. No blood, no urine, no feces. Sorry. Okay, that'll give you an automatic 0. So you can test anything else. Okay, you can test shampoo. You can test most everything in your fridge. You can test basically anything else. Okay, I'll even let you test saliva. Here is the key, though. All right, is everybody listening? Do not put these pH papers into things. Take a toothpick, take your finger, take a cotton swab, get a sample of it, and then put it on the pH strip. Because the pH paper has about 3 or 4 different chemicals on it. You don't want to put it in food or other things. Okay, so you're testing it on the pH paper. Once you've tested it, you're going to use your color strip that you've got to figure out what the pH is. You've got to do that rather quickly because it will change. So find it rather quickly, write down what you're testing, write the pH from your color strip, then put your piece of paper right here and tape it on. Do not wait to get that number, that pH number, because after you tape it, tape has its own pH. So they'll all end up looking about the same. Okay, I'm just doing that so I know that you've done it yourself. Okay? But it's a really quick, easy thing. You can test anything you've got in your house except for urine, poo, and blood. Okay? So once you get that done, yes, that happened. So then I had to make that exclusion. Okay? So now, your analysis of that is you're going to then take all the things, the 20 things that you've tested, and you're going to put it on a pH scale from 0 to 14. I don't want you writing number 6 is number 2. That's not going to help you for the rest of the thing. I need to put on number 6 that it was ketchup that I tested, or milk, or whatever I tested, put that there. So as you start putting things on this pH scale, that you'll be able to see what things are grouping together, what types of things are grouping together. So you can answer the rest of the questions. If you just put numbers here, you're not going to be able to see it, and I won't be able to see what you did. So I want you to put what you tested on this pH scale, okay? Then down here it just says what areas of the pH scale are basic or alkaline, what the pH scale is acid, and that's actually on your little colored paper for most of you. What tends to be most basic that you've tested, what tends to be most acidic, what is the most basic product you tested, and then we'll learn how to do number 7 and number 9 next time when you come back. So you've got to have this part of the lab done when you come back, then you can finish 7 and 9 and turn it in. Okay? Then what was the most acidic, and then 3 sentences of what you learned. You're going to go all the way through. Your only ones you're not going to be able to answer until next time are 7 and 9. Okay?
So if they have like the same pH, we just write.
Yeah, you're just going to keep writing across if they have the same pH. So I have 5 things that have 6. I'm just going to keep writing across on number 6. Okay, does that make sense? Pretty easy. Okay, so what we're going to do today is we're going to start our notes. And to do that, we just finished quiz 10.1. You're going to have assignment 10.1 today. Most of kids last period were able to finish 10.1 assignment, so you didn't have homework over the weekend other than the lab. Okay, other than the lab, you'll have that lab for homework. Whoops, I got to go back up. Woo, I got to go all the way out. Sorry. Okay, so we're going to learn a lot about acids and bases today. The first thing we're going to do is we're going to do a group activity. Instead of the 15 minutes, though, I'm only going to give you 8. So you need to listen. We've got a few people missing, but I'm going to get you into groups of 3 to 4. So I'm going to have this group of 3 work together. I'm going to have this group of 4 right here work together. So Lauren, you're going to be with these 3. Okay, and I'm going to have you 3 work together, you 4 work together. Javier, I'm going to have you move with these 4 right here, on the edge right here. These 4 work together, and then I'm going to have you 3 work together, and you 3 work together. Okay? Okay, so what we're going to do is I'm going to give you a package of cards. You need to elect within your group one person who's going to be scribe for your group, and one person who's going to write the stuff on the board when we're done. Okay? So, I'm going to give you this really quickly for your group. You need to turn so you can all use this together. Okay? So, front row, you're probably going to have to turn around and go to the second row. Yeah, we are. We're going to come back to notes in just a minute, but we're going to do this activity first. So you guys' stuff is right here with Lauren. Lauren probably scoot over and these guys just turn around. Okay, so what you're going to do, I'm going to give you some hints here. This instruction's also in here. So somebody that's your scribe has got to have a piece of paper you're writing down everything you can think of. You're going to put these cards out. Find as many ways to group them as you can. As many ways to group them as you can. Math equations. Oh my gosh, it's math and chemistry. Okay, there are 4 numbers on each card. There are 4 numbers on each card. Find a way to relate them. Can you add them together and get the same number? Can you multiply them and get the same number? Can you take 10 to the power and get another number on there? Can you take minus the log and get another number? So you're going to need a calculator. If you don't have a calculator, there's some in the sink. Okay? I've given you all this instruction, so this is part of the 15 minutes, but you only get 8. You're trying to find out, so on one of these cards in here, let's pull out one real quick. There are 4 numbers. Okay? There's pH, POH, concentration of H, and concentration of OH. You're trying to find a way that these relate. Okay? All right, you've got 8 minutes. Find out, write as many down as you can. Scribe, you're going to have to write real fast. Make sure that everybody's name is on that paper because we're going to hand it in. Bring it back together and talk. So basically, this was an activity to get you involved in using pH, POH, concentration of hydroxide, which was the bracket OH minus, and concentration of hydrogen, which is the bracket H plus. So you found a lot of different ways that you can sort into groups the things that I had on the cards. You're actually going to be sorting those with your lab that you're doing, right? Okay, now on the other side, where it comes to the math equation, I really didn't see what I wanted there. Do you still have the cards out? I want you to look at the cards. Okay? If I add 2 numbers on there, and I always get the same number, what 2 numbers would it be?
Oh, the pH and the POH. Yeah.
pH and the POH equal 14. So that was one of the ones I was looking for. pH plus POH always equals 14. Okay, anybody got another one that they might think? No, these ones. Okay, I was also looking for if you took the concentration of hydrogen times the concentration of OH minus, you'll always end up with 10 to the minus 14. You just times the 2 together. Just times the 2 together. If I took minus the log of the of the concentration of hydroxide, I would get POH. If I took 10 to the minus POH, I would get the concentration of hydroxide. So there's a lot of equations that go back and forth. I'm just mentioning a couple of them. We're going to talk about a lot of them next time. Okay? So go ahead and put your cards back in the container. Somebody that did not have a job, give them the job of bringing everything back up in the container and putting it right on my front desk up here. Okay, here we go. So there's 2 things that we're going to be working on a lot, or working with a lot. Okay, focusing, guys. Phones away. I don't care. Okay, phones away. So we're going to be working with the hydronium ion, which you saw as an H plus ion on the cards, and the hydroxide ion, which is the OH minus on the cards. A lot of times you'll see it as a hydrogen in brackets like this, or like this, or like this. The brackets just mean concentration in molarity. Okay? So, yes? Yep, the hydronium ion is the H3O plus, sometimes shortcutted as H plus. Okay, that's known as a hydronium ion. A hydroxide ion is the OH minus ion. Okay? You'll need to know that. You need to be able to tell me what it is. Okay? Going forward here, we're going to watch a little video just to annoy you. Okay, so that was just a fun one. We are going to talk about some acids and what they do. Acids are sour, and they're like lemon. Okay, so when you think lemon, it's sour. Bases are more bitter, like soap. Okay, or I've heard earwax. I don't want to test that out. One of my professors at college, and I just wasn't
He's like,
interested.
"Are you gonna try?"
No. Okay, so also caffeine is a base, and it's a weak base, so it has a little bit of bitter to it too.
Oh, don't acids like in soda ruin like your teeth?
Mm-hmm.
Because they're why?
Because they love to eat enamel, and calcium is a metal, and so it eats away. Okay, so we're going to be doing. Okay, so focusing going forward, there are two different definitions of acids that we're going to be using. The first one we're going to be talking about is Arrhenius's. Arrhenius, its definition of an acid is sort of like the center of a bullseye. It'll hit the most strong acids and bases, but it won't touch anything else. So by Arrhenius's definition, an acid produces an H plus ion, or a hydronium ion. A base will produce an OH minus ion. Yes?
So if it's an acid, the H will be in the front always?
Yep. For Arrhenius, the acid, the H will be in the front. Okay? So it will produce an H plus ion. So as I'm looking at this, NaOH, NaOH gives me an OH, so it's my base. The HCl gives me an H, so it's my acid. These will make what we call a neutralization reaction, in which we get a salt of some kind and water. Okay, so we're still doing OI. Outsides go together to make NaCl, and the I part of the OI is insides go together, HOH makes water. Okay, so that's known as a neutralization reaction, or a strong acid, strong base reaction.
On the side of the right?
Yeah. Now I'm going to have more on the slides than you have actual written areas for you, so you're welcome to add them in. It might help you to do better. The notes are just bare bone, minimum amount that you need. Okay, going forward here.
Wait, can you go back for a second?
Be nice. Okay, so looking at this, would this be an acid or a base? Why?
Because it's an H in first place.
Okay, it has an H here, and it's giving off an H, so that tells me it's going to be an acid. What about the NaOH?
Base.
Base, because it gives off an OH. Now, the problem with Arrhenius is that not all bases have OHs. And so we have to come up with another theory, and that theory is Bronsted-Lowry. And Bronsted and Lowry are two different guys in different places in the world, and they came up with the same theory at the same time. So they both get credit for doing it. This is their definition. An acid is a proton donor, and a base is a proton acceptor. So what's a proton? Well, proton is just a hydrogen without its electron. Okay? So on this one, the way that you can recognize it really fast is the products are always going to have a charge, because we're just moving a proton from one to the other. So they're always going to end up with a charge. And they end up in pairs. So on this reaction right here, we've got some conjugate pairs. This acid over here will become a base on the other side, and we actually call it a conjugate base. You'll see me write it just CB, because it's lost its hydrogen. Okay? This set right here, this base becomes a conjugate acid. So you'll see me write that Ca, because it has gained a hydrogen. Okay? Now, conjugate just means if I go backwards, that's the one that's going to act like an acid or a base. So conjugate just means it's on the product side right now, and so if I go backwards, it's going to act like an acid or a base. Notice that Bronsted-Lowry has, what kind of arrow is that? We just got through with it. Equilibrium area, where Arrhenius's arrow was all straight forward. It only goes one way. Okay, so this reaction can go either way depending on which one I force or which one I put pressure on, right? We just got over that reaction rate stuff. And I will put this video up on your canvas so you can watch that. Oh, did I go too fast? Okay, sorry. Okay, we got another little video. So conjugate base will have a less hydrogen, yes. So let's go forward here. So here I have some acids. To write the conjugate base, I'm going to, what's happening to the acid by definition? What does an acid do? Donates a hydrogen. What does a base do? Accepts hydrogen. So we have acids here, so they're going to donate a hydrogen and leave behind the conjugate base. So what would be the conjugate base of this one? HF. Okay, what would be the conjugate base of H2SO4? HSO4 with a negative charge, right? Because it gave away one positive. Okay, what about HNO3? What's the conjugate base of that one?
NO3 negative.
Good, NO3 negative. What about H2CO3? HCO3 negative. And you'll be doing this in your assignment tonight. All we're doing is taking one hydrogen off, and when we take one hydrogen off, we're taking one positive charge away. Okay, yes? No, because it already had a positive charge. Yep. So the blue is acids. The black ones that I wrote would be the conjugate bases. Okay, so now we're going to go and switch it. Here are some bases, and we're going to make the conjugate acid. So what did the bases do? Accept a hydrogen. So to accept a hydrogen,
NH4 positive.
good, NH4 positive. Now, this is the hard part, and this is one of the questions I got asked last time. Well, how do I know if the H goes first or if it goes last? Because sometimes it's first and sometimes it's last. For nitrogen and carbon, if it's written last, write it last. Okay? For most other things, we put hydrogen first. Okay? So on this one, this is one of the tricky ones because this one has carbon and hydrogen. This is an organic way to write acetate ion. This is an inorganic on the bottom. I like to write it this way here. So on this one, we're just going to put the H up in front so that we know it's an acid. Okay? Because that C2H3O2 is a group. It hangs together. It's one of our polyatomics. So I don't want to insert a hydrogen in the middle of it. Okay, does that make sense? It's sort of like having a gang at school and all of a sudden somebody says, you're going to have this person be the head of your group. Oh, yeah. Yeah.
On the assignment, it says from the conjugate acid,
Mm-hmm.
water.
Water can be an acid or a base. It's called amphoteric. So because of that, depending on who it's with, it's one of those group people that can go with this group and be fine, or go with this group and be fine. So it can either give a hydrogen and become OH, or it can gain a hydrogen and become a hydronium ion. Okay, good question. Okay, so let's go on this one. What would be the conjugate acid of this one? HPO4 what? -2. We only change it by 1. Okay, what about the bottom one? Good. So not too hard, right? Pretty easy. Yes, ma'am. If it's no charge and we're adding a hydrogen, we add a positive.
But if we're taking away,
Then we take away a positive.
okay, and then
See the difference? Okay.
Oh, wait. No.
What?
I need to write these down.
You can do this without seeing, yeah. NH3, because this is remember on NH3 when we draw it like this, it goes like this, right? That hydrogen's going to come down and be right here. So because of it, I'm not really changing that group. it's all together. This big nasty thing is a big complex, and that hydrogen's just going to come up and bump up to it. Okay? Yes. One more time. Bronsted and Lowry. Yep. Okay, I will have it up on there for YouTube, and you can click it from your canvas. Okay, so let's do this really quickly. I need to figure out what these are, what pairs. I need to label the acid, the base, the conjugate acid, conjugate base. These are not in your notes. I don't believe so. Okay, these are not in your notes. This is practice because this is going to be stuff that you're going to be doing in your assignments. I wanted to have some practice. If you want to write it down or take a picture, you can. So, what is HBr? You might want to wait until we put all this on there. You ready? Acid. And it connects with this, right? So if it's an acid on this side, it's going to be a conjugate base. Good. So that means this has to act as a base, and its partner is going to be a conjugate acid. Nope. Okay, what's this one? It doesn't have any hydrogen, so it has to be a base, right? So on the other side, it's connected with a hydrogen, so it's going to be conjugate acid. Water here acts as a what? Acid, because on this side it's lost a hydrogen, so it makes it a conjugate base. See how that works?
Yeah.
Everybody, am I losing anybody? Yes.
Okay, so like if it didn't have the other side, would you be able to tell which one was the acid?
Which one could donate a hydrogen? This one's one of my, we'll talk about strong acids here in just a minute, but water can be an acid or a base, but it's not strong either way.
So like if on the letter A, if you didn't have the other side.
If I didn't have the other side, I would have to know about strong acids and strong bases. We haven't learned that quite yet, but we will. And you could do it, yes. That's what you're asking me, yes? Okay. All right, let's keep going. Looking at the next one.
Acid. Oh, wait. Acid. Wait.
No, yeah, it'd be acid.
Acid.
Acid, okay? I'm going to go in order. Whoa.
Base.
Base.
C. Yeah. C. Yeah.
Oh, because negative, so that one it would have been taken away.
Okay, so what about this one? Ooh.
Acid.
Acid, base, conjugate base. Good. Okay, what now the next one?
Base. Conjugate acid.
Okay, not hard, right? If you want to take a picture real quick, take a picture, because it's not in your notes.
Oh, wait.
But it will be up on Canvas, so if you want to go back through it again with us, you can on Canvas, okay? Got it?
Fires tend to be negative.
Could be, yeah. But we've got a negative conjugate acid here, so you got to be careful. Okay, so going forward. Okay, this is sort of a recap. What was the first theory we learned about?
Arrhenius.
Arrhenius, and that was about acids donate H+, bases donate OH-. Who was one layer out? So Arrhenius only does just a small amount of acids and bases. So we needed another theory that had more farther out, Bronsted-Lowry. And Bronsted-Lowry was about what? Donating what? Hydrogens, which are considered protons because it doesn't have the electron, right? So it's just a proton. So this is sort of what it looks like. Now, if you go into other chemistries, there's one more layer out. It's called Lewis. Yes, it has to do with Lewis dot or electrons. And it covers more acids and bases. But we're just worried about these two in general chem. Okay, so to summarize, Arrhenius is acid and bases. Acid base makes salt and water. Always will make salt and water. Because you have H and OH, and H and OH always make water. And whatever's left over makes the salt. Okay? This is called a strong acid, strong base, or a neutralization reaction. Then we have Bronsted-Lowry, and the way you can tell on Bronsted-Lowry is you're always going to end up with a positive and a negative, or some charged particles. These are not going to be not charged. Okay? And you're going to have a double-sided arrow. I couldn't find the arrow that goes like this. That's the arrow that's supposed to be there, an equilibrium arrow. Notice this arrow is one way only. Okay? So a couple ways we can remember that. Remember, looking side to side, you need to be able to say acid, base, conjugate base. That's just if I was on the product side going backwards. Okay, so we need to be able to identify the 6 strong acids and the 6 strong bases. I'm going to give you what they are, which is right there, but I'm also going to give you a way to remember it from the periodic table. There are 6 strong acids and 6 strong bases. If you memorize these, everything else is weak. Okay, so we're going to start with the acids. The acids are on the right-hand side of the periodic table. They start with nitrogen. NHNO3 is nitric acid. Then it goes to sulfur, H2SO4. So I've added a hydrogen and I've added an oxygen when I get to that one, H2SO4. Then it becomes HClO3, or HClO4, sorry, perchloric acid. And you'll notice I've got 2 chlorines there. That's because I've talked about my 3 oxy acids, and now there are 3 binary acids, meaning no oxygen. And they are HCl, hydrochloric acid, HBr, and HI, hydrobromic and hydroiodic acid. So those are my 6 strong acids. I call it the swoop and down. So the swoop has the oxy in it, and it goes HNO3, H2SO4, HClO4, sorry. Okay? On the opposite side, we're going to get the bases. The bases form a tetras pattern. So on the tetras pattern, we start with lithium hydroxide, sodium hydroxide, and potassium hydroxide. Then we slide over to the second column and go calcium hydroxide, strontium hydroxide, and barium hydroxide. Notice when we slide over to the second column, they have 2 hydroxides with them. So first column, 1 hydroxide, second column, 2 hydroxide. But it is a tetras pattern. So bases on the left, acids on the right. Okay? Acids are on the right. Okay? That's just a way to remember them. If you just want to take and memorize the 6 strong acids and bases, you can. That's just a way to get them from the periodic table. Okay? All right, so just a quick review on naming, because we're in acids and we got to remember how to name acids. So if I have 2 elements, hydrogen and 1 other element, we would normally end it with IDE because there's 2. But we don't for an acid. We name it hydro, whatever it's with, ic and acid. So for instance, HCl becomes hydrochloric acid. Okay? Then I gave you a little hint. This was right before Thanksgiving, remember? We were talking about acids, and I said, oh, I ate, and I got sick because I ate too much at Thanksgiving. So 8 becomes ic, and when it hits my stomach, acid. So if I have a polyatomic and it ends in 8, like phosphate, which is PO4, it has a -3 charge, it would be H3PO4. This would be phosphoric acid. Now remember, PS, by the way, sulfur and phosphorus get their way. They get their OR and their UR back. Everybody else is just going to be ic and acid, but the phosphorus and sulfur get their OR and UR back. Okay, I gave you a hint on ite. OS, we're going to be in a fight. Yep, so in an acid situation, if I ended in ite, fight, OS, we're going to get in a fight. So we change it to OS. Okay, so that was just a quick remind on how to do that. Yes?
Why are there strong acids and bases considered strong?
That's what we're going into next. Okay, just a real quick before we hit that. This is a breakdown real fast. If you're with acids, you have 2 elements. You're going to go hydro, ic, and acid. If you're 3 elements, you do not use hydro. Okay? You look at the ending of the polyatomic. If it was 8, it goes to ic and add acid. If it was ite, it goes to us and add acid. So that's just a really quick remember how to do it in a flow chart way. So what does strong mean? Strong means it's going to 100% split into its ions when it hits water. 100% go to its ions. So I'm not going to have any left together. So strong HCl splits into H plus and Cl minus. I don't have any HCl together at the end. Weak means only 1 to 5% it will split. So if I have weak, I mostly would have together. That would be like HF. Hydrofluoric acid mostly sticks together as HF, not as H plus and F minus. Okay? There's very few that's in between, believe it or not. There's not very many that are in between. Magnesium hydroxide would be a stronger-ish base, but not strong base. So that would probably be in your 80%. There's a couple, but they're mostly either weak or strong. There's not medium strength. Okay, so reviewing of the strong acids. Nitric, sulfuric, only the first hydrogen. Perchloric, hydrochloric, hydrobromic, hydroiodic. Remember, hydroiodic's very friendly and says hi and then eats you alive.
Oh, really?
Yeah. Yeah, you don't want it on you. It will eat bone and everything. Hydroiodic, pretty fast.
So if somebody just like poured that on you, you'd be gone in seconds? Or like...
Yeah, it would be a very painful death, but yes. Okay, going forward, bases. Remember, this is Tetris, yes. We're getting there. Okay, so first column, lithium hydroxide, sodium hydroxide, potassium hydroxide. Second column, 2 OHs, calcium hydroxide, strontium hydroxide, barium hydroxide. They split totally, 100% into ions. Okay, that's the Tetris pattern. Now, when we talk about pH and pOH, they're sort of opposite each other. Remember, they always have to equal 14. We sort of learned that just a minute ago. If I have a low pH, then I have a high pOH. So the pOH down here would have been 14 for pOH. If my pH is 14, then my pOH is 0. Okay? So they're just exactly opposite because they always have to equal 14. So we get this little grid here. I can have a pH of a -2, and I can have a pOH of a 16. Those are really, really, really strong acids and bases. Battery acid is about a 1, pH of 1. This would be about my 18 molar sulfuric acid that I have in the back. Okay? All right, we're not going to listen to that again. We're going to skip over, sorry. If we have time at the end, I'll annoy you with it more. Okay, so this is to give you some ideas for your lab. So as we're looking at this, you can sort of see battery acid at 1, lemon juice at 2, vinegar at 3. We have acid rain between 1 and 5, and then normal rain between about 5 and 6.5. Normal stream pH between 6 and 8. And then we've got ammonia and lye coming down. Here's another kind of chart that has a lot of different things that you can test. If you'll notice on this one, different pops have different pH. So if we look at Coke, it's 2.6, but if we look at 7-Up, it's 4.3. If we look at root beer, it's 6.6. So you can test different beverages. Just because it's a pop does not mean it's going to have the same pH. Okay, so you could test different things. Pickle juice, Pepto-Bismol, skim milk versus regular milk. We're not going to test human blood, okay, but we can test most of the other things. I know, you guys really want to do that. Okay, so what did you test? This is just a reminder on your thing. You're going to write down before you test it, you're going to take a toothpick or a Q-tip or even your finger, take a sample of whatever you want to sample and put it on the pH paper. Quickly get the reading, whatever the test, whatever it looks like, especially if you're doing bleach, because bleach will give you a dark purple to start with and then it will go white. So you want that first reading, whatever it is. Take the pH paper on. Then go to the next one. Okay? Do all your 20 at one time, because if you don't, you're going to lose those pH papers. Yes? You're going to use all of those, but you need to cut them so you have 20 pieces. Now, if you want to test blood and pee and urine, you can, but don't put it on that paper. So you're going to cut your papers a little bit smaller, and then you can test it, but don't put it on my paper to turn in. Throw it away. Okay? So if you're really, really curious, you could do that. Okay, so again, whoops, I went the wrong way. Okay, whoops, here we go. So to write a dissociation equation, we're going to write the dissociation equation. We're just going to pull it apart to its ions. That's all we're doing. So this would be taking a hydrogen off, H plus, always AQ for a cute little ion, plus C2H3O2 minus AQ for a cute little ion. That's a dissociation equation. That's it. I just split it into its ions. For an acid base, I only take one hydrogen off at a time. Only one hydrogen off at a time. If it's a strong acid or strong base, for the strong bases, I split it up totally. Strong base, straight arrow. No double-sided arrow for strong acid, strong base. It only goes one way. So I get a calcium plus 2, AQ, because it's in the second column. OH minus, I have 2 of them. AQ, and I'm done. That's all I have to do for dissociation. Okay? Any questions about doing a dissociation equation? Just keep it up there for a minute. Okay.
How do you know if it's AQ?
Anytime I have a charge, it's going to be AQ. So if I have a charge, it's going to be AQ. Just the way I remember it, AQ, it really means aqueous, but I think of it as a cute little ion, so it has to have a charge. That's how I remember it. Okay, are we okay to move forward? Okay, so this one is just what we've been doing before. When we were about November, we're doing OI, outsides and insides. So outsides are going to go together, and insides are going to go together on the other side. What am I going to make? Okay, Mg and PO4. Mg has a +2, PO4 has a -3 charge. What's the common factor? Nope. Common factor between 2 and 3. What do they both go into? 6. So how to make 6 with magnesium? I need 3 of them. How many phosphates do I need? 2. Then I'm going to erase those charges. Plus, insides, H and OH make water. Always makes water. Okay, is it balanced? Side to side. Is it balanced? No. Let's look at our magnesiums. How many do we have on the left? How many do we have on the right? We need 3 on the left, right? Let's look at our phosphates, our phosphorus. We have 1 on the left. How many on the right? 2. So I need to put a 2 here. Remember, I always leave H and O till very last. So ho, 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 like Christmas at the end of the year. Santa says ho, ho, ho. That's how I remember it. Leave hydrogen, oxygen, very last. So hydrogen, we have 2 times 3 is 6 in the magnesium hydroxide. And in the phosphoric acid, we have another 6. So we have a total of 12 hydrogens on this side. On this side, we have 2. So we need to put a 6 in front, so that would make 12. Okay, oxygens, we've got 3 times 2, so 6 here, plus 2 times 4 is 8, gives me 14. Oxygens here, 8 plus 6 gives me 14, and I'm balanced. We're good to go. Okay? Going forward. Okay, I would like you to write this on the back of your green sheet on your notes. I'm going to give you a few minutes. I want you to identify the acid, the base, the conjugate acid, and the conjugate base. I want to see if you can do it.
You can just say A, B, and John, right?
Yeah, you can put A, B, C, A, C, B. You don't have to write out conjugate acid, conjugate base.
Water thing?
Yeah, it should be at equilibrium. I could not find that arrow. I could find this arrow, but I couldn't find the double-sided. So assume they're double-sided. I finally found it, but it won't take it in PowerPoint. It's a special code you have to put in.
Try to enter it as a PDF.
I'm trying to find it as a picture, so I can just put it in as a picture, but I just haven't gone back on a lot of my older notes and done it. Yeah, I can snip it and save it that way too. I just haven't gone back and it takes time. Okay, I'm going to give you about another minute.
Okay.
Got it?
Think so. I mean, is that all we had to do? Was write acid and conjugate base?
Acid, base, conjugate acid, conjugate base. Yep. For 1 and 2.
There's like a 50-50 chance.
Actually, it's 25%.
Like,
Unless you know which side is which, yes. Then it would take it down to 50-50.
Well, like, I use C's like 8 students and then a CL, and you're like, oh, that's something.
Wait, what else? What
Da
is
da
the-
da 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 da.
Like, what doesn't have to?
Some plastics can contain it. Some kinds of glass can too. Okay, we ready?
Wait, hold on.
Okay, that's okay. Okay, when I show the answers, if you get all 8, I want a thumbs up. If you get 6 to 7, thumbs sideways. If you're below 6, I want your thumbs down, so I know who needs help. Okay, that's just for me, so I know where I need to go to help you, because this is part of what you're doing for your assignment. We okay to go forward? Okay, here we go. Thumbs up, you got all 8. Thumbs sideways, 6 to 8, 6 to 7, and thumbs down, I didn't get it. Oh. Okay, so now you are working on your assignment, and you've got a few minutes to get it done. It doesn't take very long. Okay, assignment number 1. You get assignment number 1 done, then all you have for homework is your lab. Yes. Yep, let me stop this real quick.